So we've got set up, we've got access to PyTorch, we've got a Google Colab instance running here, we've got a GPU because we've gone up to runtime, change runtime type, hardware accelerator. You won't necessarily need a GPU for this entire notebook, but I just wanted to show you how to get access to a GPU because we're going to be using them later on. So let's get rid of this. And one last thing, how I'd recommend going through this course is in a split window fashion. So for example, you might have the video where I'm talking right now and writing code on the left side, and then you might have another window over the other side with your own Colab window, and you can go new notebook, call it whatever you want, my notebook. You could call it very similar to what we're writing here. And then if I write code over on this side, on this video, you can't copy it of course, but you'll write the same code here and then go on and go on and go on. And if you get stuck, of course, you have the reference notebook and you have an opportunity to ask a question here. So with that being said, let's get started. The first thing we're going to have a look at in PyTorch is an introduction to tensors. So tensors are the main building block of deep learning in general, or data. And so you may have watched the video, what is a tensor? For the sake of this course, tensors are a way to represent data, especially multi-dimensional data, numeric data that is. But that numeric data represents something else. So let's go in here, creating tensors. So the first kind of tensor we're going to create is actually called a scalar. I know I'm going to throw a lot of different names of things at you, but it's important that you're aware of such nomenclature. Even though in PyTorch almost everything is referred to as a tensor, there are different kinds of tensors. And just to exemplify the fact that we're using a reference notebook, if we go up here, we can see we have importing PyTorch, we've done that. Now we're up to introduction to tensors, we've got creating tensors, and we've got scalar, etc., etc., etc. So this is what we're going to be working through. Let's do it together. So scalar, the way to, oops, what have I done there? The way to create a tensor in PyTorch, we're going to call this scalar equals torch.tensor, and we're going to fill it with the number 7. And then if we press or retype in scalar, what do we get back? 7. Wonderful. And it's got the tensor data type here. So how would we find out about what torch.tensor actually is? Well, let me show you how I would. We go to torch.tensor. There we go. We've got the documentation. So this is possibly the most common class in PyTorch other than one we're going to see later on that you'll use, which is torch.nn. Basically, everything in PyTorch works off torch.tensor. And if you'd like to learn more, you can read through here. In fact, I would encourage you to read through this documentation for at least 10 minutes after you finish some videos here. So with that being said, I'm going to link that in here. So PyTorch tensors are created using torch.tensor. And then we've got that link there. Oops. Typos galore, Daniel. Come on. You're better than this. No, I'm kidding. There's going to be typos galore through the whole course. Okay, now, what are some attributes of a scalar? So some details about scalars. Let's find out how many dimensions there are. Oh, and by the way, this warning, perfect timing. Google Colab will give you some warnings here, depending on whether you're using a GPU or not. Now, the reason being is because Google Colab provides GPUs to you and I for free. However, GPUs aren't free for Google to provide. So if we're not using a GPU, we can save some resources, allow someone else to use a GPU by going to none. And of course, we can always switch this back. So I'm going to turn my GPU off so that someone else out there, I'm not using the GPU at the moment, they can use it. So what you're also going to see is if your Google Colab instance ever restarts up here, we're going to have to rerun these cells. So if you stop coding for a while, go have a break, and then come back and you start your notebook again, that's one downside of Google Colab, is that it resets after a few hours. How many hours? I don't know exactly. The reset time is longer if you have the Pro subscription, but because it's a free service and the way Google calculate usage and all that sort of stuff, I can't give a conclusive evidence or conclusive answer on how long until it resets. But just know, if you come back, you might have to rerun some of your cells, and you can do that with Shift and Enter. So a scalar has no dimensions, right? It's just a single number. But then we move on to the next thing. Or actually, if we wanted to get this number out of a tensor type, we can use scalar.item. This is going to give it back as just a regular Python integer. Wonderful. There we got the number 7 back. Get tensor back as Python int. Now, the next thing that we have is a vector. So let's write in here, vector, which again is going to be created with torch.tensor, but you will also hear the word vector used a lot too. Now, what is the deal? Oops, 7.7. Google Colab's autocomplete is a bit funny. It doesn't always do the thing you want it to. So if we see a vector, we've got 2 numbers here. And then if we wanted to find out what is a vector, so a vector usually has magnitude and direction. So what we're going to see later on is, there we go, magnitude, how far it's going and which way it's going. And then if we plotted it, we've got, yeah, a vector equals, the magnitude would be the length here and the direction would be where it's pointing. And, oh, here we go, scalar, vector, matrix, tensor. This is what we're working on as well. So the thing about vectors, how they differ with scalars is how I just remember them, is rather than magnitude and direction, is a vector typically has more than one number. So if we go vector ndim, how many dimensions does it have? It has 1 dimension, which is kind of confusing, but when we see tensors with more than 1 dimension, it'll make sense. And another way that I remember how many dimensions something has is by the number of square brackets. So let's check out something else. Maybe we go vector.shape. Shape is 2. So the difference between dimension, so dimension is like number of square brackets. And when I say, even though there's 2 here, I mean number of pairs of closing square brackets. So there's 1 pair of closing square brackets here. But the shape of the vector is 2. So we have 2 by 1 elements. So that means a total of 2 elements. Now, if we wanted to step things up a notch, let's create a matrix. So this is another term you're going to hear. And you might be wondering why I'm capitalizing matrix. Well, I'll explain that in a second. Matrix equals torch.tensor. And we're going to put 2 square brackets here. You might be thinking, what could the 2 square brackets mean? Or actually, that's a little bit of a challenge. If 1 pair of square brackets had an ndim of 1, what will the ndim be, number of dimensions, of 2 square brackets? So let's create this matrix. Beautiful. So we've got another tensor here. Again, as I said, these things have different names, like the traditional name of scalar, vector, matrix, but they're all still a torch.tensor. That's a little bit confusing, but the thing you should remember in PyTorch is basically anytime you encode data into numbers, it's of a tensor data type. And so now, how many number of dimensions do you think a matrix has? It has 2. So there we go, we have 2 square brackets. So if we wanted to get matrix, let's index on the 0th axis. Let's see what happens there. So we get 7 and 8, and then we get off the first dimension. 9 and 10. So this is where the square brackets, the pairings come into play. We've got 2 square bracket pairings on the outside here, so we have an ndim of 2. Now if we get the shape of the matrix, what do you think the shape will be? 2 by 2. So we've got 2 numbers here by 2. So we have a total of 4 elements in there. So we're covering a fair bit of ground here, nice and quick, but that's going to be the teaching style of this course, is we're going to get quite hands-on and writing a lot of code and just interacting with it rather than continually going back over and discussing what's going on here. The best way to find out what's happening within a matrix is to write more code that's similar to these matrices here. But let's not stop at matrix. Let's upgrade to a tensor now. So I might put this in capitals as well. And I haven't explained what the capitals mean yet, but we'll see that in a second. So let's go torch.tensor. And what we're going to do is, this time we've done 1 square bracket pairing, we've done 2 square bracket pairings, let's do 3 square bracket pairings and just get a little bit adventurous, all right? And so you might be thinking at the moment, this is quite tedious. I'm just going to write a bunch of random numbers here, 1, 2, 3, 3, 6, 9, 2, 5, 4. Now, you might be thinking, Daniel, you've said tensors could have millions of numbers. If we had to write them all by hand, that would be quite tedious. And yes, you're completely right. The fact is, though, that most of the time you won't be crafting tensors by hand. PyTorch will do a lot of that behind the scenes. However, it's important to know that these are the fundamental building blocks of the models and the deep learning neural networks that we're going to be building. So, tensor, capitals as well. We have 3 square brackets. So, or 3 square bracket pairings. I'm just going to refer to 3 square brackets at the very start because they're going to be paired down here. How many ndim, or number of dimensions, do you think our tensor will have? 3, wonderful. And what do you think the shape of our tensor is? We have 3 elements here, we have 3 elements here, 3 elements here, and we have 1, 2, 3. So maybe our tensor has a shape of 1 by 3 by 3. What does that mean? Well, we've got 3 by 1, 2, 3. That's the second square bracket there. By 1. So that's the first dimension there, or the 0th dimension, because remember, PyTorch is 0 indexed. We have, well, let's just, instead of talking about it, let's just get on the 0th axis and see what happens with the 0th dimension. There we go. Okay, so this is the far left one, 0, which is very confusing because we've got a 1 here. But, so we've got, oops, don't mean that. What this is saying is we've got 1 3 by 3 shaped tensor. So very outer bracket matches up with this, number 1 here. And then this 3 matches up with the next one here, which is 1, 2, 3. And then this 3 matches up with this one, 1, 2, 3. Now, if you'd like to see this with a pretty picture, we can see it here. So dim 0 lines up. So the blue bracket, the very outer one, lines up with the 1. Then dim equals 1, this one here, the middle bracket, lines up with the middle dimension here. And then dim equals 2, the very inner, lines up with these 3 here. So again, this is going to take a lot of practice. It's taken me a lot of practice to understand the dimensions of tensors, but to practice, I would like you to write out your own tensor of, you can put however many square brackets you want, and then just interact with the ndim, shape, and indexing, just as I've done here, but you can put any combination of numbers inside this tensor. That's a little bit of practice before the next video. So give that a shot, and then we'll move on to the next topic. I'll see you there.